In this video, we're going to take a quick look at how we can prove triangles to be similar. And we have three similarity theorems for triangles that we'll talk about. We have the angle-angle similarity theorem, we have the side-side-side similarity, and the side-angle-side similarity theorem. So let's dive into these. So first of all, let's talk about how we use the definition of similarity. The definition of similar polygons says that two polygons, or in this case just triangles, are similar if we know that corresponding angles are congruent and corresponding sides are proportional. Okay, so if we have two triangles right now with nothing marked, we have no idea if these are similar. But if we said something like this, that this angle and this angle are congruent, this angle is congruent to this angle, and this angle here, put 3 marks there, is congruent to this angle here. Well, now we know all the angles are congruent, and then let's say we knew something like this was 1 unit long, and this is 2, this is maybe 4, and this is 8. This might be, well, it looks like a right triangle, but we don't know what it is. Let's say this is 6, and this is 12. All right, so if we knew that, we now can see that, hey, all the sides are proportional. 1 is to 2, as 4 is to 8, as 6 is to 12. They're all a half. All right, so all the sides are proportional, all the angles are congruent. So we have 3 angles, angle, that we've checked out, and 3 sides. So we've checked out 6 parts, and they all agree with this definition. So we could say, yep, these triangles are congruent. And we might say, let's go ahead and give these some points, A, B, C, and D, E, F. We could say, by the definition, we've just explained, just shown, that triangle ABC is similar to triangle DEF. And that's our similarity statement here. This is a similarity statement. Okay, the ratio, the similarity ratio here is 1 to 2. The ratio is the same. 1 over 2, or 1 to 2. So all the sides are proportional, all the angles are congruent, so these two triangles are similar. Now, that was comparing 6 things, but we want to know if the two triangles are similar by just looking at a few pieces of information. Let's see how we can do that. So in the past, you've probably learned about some theorems that allow us to tell if triangles are congruent. Congruent means exactly the same. But now we want to know what makes two triangles similar. The first one is angle-angle similarity. And we're not going to take time to prove it here. Actually, this is technically a postulate. And it turns out that if this angle is congruent to this angle, and this angle here is congruent to this angle over here, then those two triangles would have to be similar. So the angle-angle similarity theorem says that if two angles of one triangle are congruent to two angles of the other triangle, then the triangles are similar. Okay, so if we called this triangle 1 and triangle 2, we could say triangle 1 is similar to triangle 2. Alright, so here's an example where we want to show that these triangles are similar, and we want to justify our answer. So we've got 2 triangles up here and down below. We know that these 2 sides are parallel. Okay, we've got a couple marks here given to us that the arrows, remember, say that these 2 lines are parallel. So since these are parallel, we got to go back and think about all our different angles. And we know that when we have parallel lines, that these angles on the inside here, these are alternate interior angles. So we know that angle E is congruent to angle A. We also know that this angle D is congruent to this angle B. and that is because they are alternate interior angles. Okay, so we can say by the alternate interior angle theorem. Alright, so we know that we have two congruent angles there, and that's good enough. We've got two angles congruent. That means the triangles have to be congruent. Okay, so we can say now that the triangles are similar. ABC is similar to triangle. Now we've got to get this in the right order. A corresponds to E, so that's E, and this B, angle B, corresponds to angle D, so that's got to come next in our statement. And then C. And the reason is by the angle similarity theorem. Okay? That's kind of our final answer there. Now the next way to show that triangles are similar is called side-side-side. So we have the side-side-side similarity theorem. And what that says is if we know that these sides are proportional, not congruent, but they have to be proportional. So if this was, let's say, 2, and this was 3, and let's say this was 5, and, oh, well, let's pick a different one. Well, that's fine. Let's go with 5. And this would be 7.5, and this is 6, and this is 9. Now, if we check carefully, we can see that these are 1.5 times bigger than their corresponding sides. So 1.5 times 2 is 3. 1.5 times 6 is 9. 1.5 times 5 is 7.5. Okay, so these triangles would be similar by side-side-side. Okay, so we could say triangle ABC and triangle DEF, if we gave these some names, are similar. Triangle DEF by the side-side-side similarity statement. We don't need to know anything about the angles. If we know all the sides are proportional, that's good enough for a triangle. So let's look at an example here. Let's say we've got two triangles that are, we're given all the sides here. We don't know anything about the angles, but we know that the sides are given to us, and we want to know if these sides are proportional. That's what we got to check. So let's check that out. So we can look at our corresponding sides, and we'll go based off the way that they look here for corresponding. We've got 15. 15 is to 10, and we have this 12.5 to this 10. Oh, let me back up. That's not right. Let's try this again. So this 15 here matches with this 12. It corresponds with this 12. So 15 is to 12, as this 12.5 is to this 10. And this 10 is to this 8. So those are the three ratios we got to compare. And we can do this a few ways. We want to see if they're equal, so we might put a little question mark here. Is that true? That's what we're trying to check. One way we could do this is we could divide this out. Okay, and if we take our calculator and we divide this out, we'll find out that this is 1.25. And this is 1.25. And this is 1.25. Remember, with a fraction, we divide the numerator divided by the denominator. And they all come out to be 1.25, which is, obviously, those are all the same. Okay? And we could also simplify the fractions. We could say, hey, divide these by 3 and 3, and we get 5 over 4. Going down to the end over here, divide these by 3. No, I'm sorry, let's divide those by 2. And that gives us 5/4. And here, well, this was a little tricky. Divide this by 2.5. 2.5 goes into here 5 times. 2.5 goes into here 4 times. That was a little trickier because of the decimal. And so we see that all the sides are proportional, so we can say that the triangles are congruent, are actually, let's say, similar by the side similarity theorem. And that would be our statement there. And our third and final theorem is the side angle side theorem. And what this tells us is that if we know that two angles are congruent, and the two sides that make those angles, or we see these angles are included in these two sides. So maybe this is 2, and this is 4, and this is 6, and this is 12. So if we know that these two sides are proportional here, like this 4 is 2 times bigger than this 2, this 12 is 2 times bigger than the 6, so the sides are proportional. 4 over 2 is the same as 12 over 6. Well, and we know the angle between them, then we can say the triangles are similar by side angle side similarity. Okay, let's try a quick example here. So here we have a picture, a lot like the one we had a couple examples ago. And in this one, we're given some different information though. We're given two sides. Here we have a shorter side in a triangle and the medium side, it looks like, and the short side over here and the medium side here. And we want to know, are these two triangles similar? So we don't know anything about the third side, so we can't use side, side, side. We don't know if these lines are parallel like we did before, so that doesn't help us. We can think about some angles here. We do have some vertical angles. These two angles are congruent by vertical angles. So we know that angle ACB is congruent to angle ECD by vertical angles. That theorem that we've talked about before. And so now the only question is, are these sides proportional? So to use side angle side similarity, we've got to know two angles that are congruent to each other, and then we've got to check the sides that make those. So we've got to check that is 2 to 3, is that equal to 4 over 6? Because this 4 corresponds with this 6, and pretty clearly it is. This fraction is 2/3, and if we simplify the second fraction, it's 2/3. So yes, they're proportional. So the sides are proportional, and the angle in between them is congruent. So we could say triangle ACB is similar to triangle, watch your order here, ECD, because the B and the D correspond, so they've got to be in the same position. Same thing with the A and the E. And our reason is by side angle side similarity. And there you have it. So to wrap it up, these are our 3 ways to prove that triangles are similar. Angle similarity, just got to know 2 angles. Side similarity, this means that all 3 sides are proportional. And side angle side similarity, 2 sides are proportional and one angle is congruent, the angle in between those 2 sides. So those are 3 ways to prove that triangles are similar, and good luck.